All right, so let's get started. We need someone to start first.
Haley, are you okay to start? Go ahead and get it over with.
Okay, go ahead. So what's your topic?
We are doing reflected XSS.
All right. So it's your turn. And I believe Haley is your teammate, right?
Yeah.
And for those who use FairGrader to evaluate this group, their other team member, Joseph Trims, is not here. So I wanted to uncheck active checkbox. So
correct. So
that's what I wanted.
Unfortunately, Joseph was supposed to do the example and walk you guys through it, but unfortunately, he was unable to complete that. So Haley and I will just do our best with what we have. But again, we did reflected XSS, just to kind of give you an overview. These attacks are just one of two types of cross-site scripting attacks. Attacks are types of injection in which malicious scripts are injected into otherwise benign or trusted websites. XSS attacks occur when an attacker uses a web application to send malicious code, generally in the form of a browser side script to different end users. In reflected attacks, the script is reflected off a web application to the victim's browser. These can appear as an error message, a search result, or any kind of response to some of the inputs you send to the server as part of the request. Attacks like these can be delivered in emails, found on a web page with a link. You just click the link, the injected code travels to the vulnerable website, reflects back to the user's browser. Here's just kind of an example to kind of show you what it looks like, kind of simplify it. The perpetrator embeds a malicious script enabling the viewing of user-sensitive or hyperlinks. A victim or visitor is email or finds a link on a website, it's on clicking the link to the website, the script is executed by the web application and browser. The browser then sends that to the perpetrator, enabling access to the attack. Some consequences of the reflected attack.
Megan, I'm sorry to apologize. Megan, I apologize to interrupting you, but it's I cannot understand anything you say. It's the
I'm sorry,
quality.
my microphone on my computer is absolutely horrible. I'm so sorry.
Do you have any other means to connect to the Hangout and use some other computer? Because it's anything you say is just blah, 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 blah.
I do not. Unfortunately, this is the only laptop that I have.
Can Haley do the presentation? I mean, or she will have her own part?
She has her own portion, so I'm doing the beginning and she's concluding at the end.
All right, let's just go ahead.
Okay.
Let's move on.
I mean, is this helping? I'm trying to get as close to my microphone as I possibly can. Okay. Professor Haley, would you be comfortable reading what I have and doing my portion since we can't understand?
Yeah. Can y'all hear me?
Yeah.
Okay.
Thank you.
Did you leave off on the consequences of reflected excess? Okay. So part of that would be the cookie theft. The attacker basically can go in and access the victim's cookies, which allows for them to see what the user is searching for, and then they ultimately send that back to their server, and they can track their sessions, which isn't a good thing. And then with key logging, it adds the attacks to the register of a keyboard, and they're listed through the keystrokes, and that can record sensitive information such as credit cards, passwords, and that's why a lot of IT departments recommend that you don't save that information to your computer because it leaves you open for attacks. And then phishing is when the attacker can insert a fake login form. So someone could send you an email and say, hey, I need you to log into your Georgia View or your Google account, and then you enter your password and not even really be from Google or the university, and then you're open for an attack. We use the next page, Megan? Okay. And then vulnerable program languages, it would be anything that's like an email, a message board, social media, MySpace. I know a lot of us remember having those back in the day. People would put their own codes in there, and then when they inserted their own code throughout their thing, whether it be to do like the cool lines that go up and down on the screen or different font colors, people could go in there and insert a URL that would ultimately attack the computer and make it look like it was doing something it should be doing, but actually wasn't. And that's why all these platforms are now monitored so it doesn't do this. You can go to the next one, okay? A lot of the vulnerable programming languages would be like Java, Flash, HTML, which is what most of our social media sites use nowadays, which is why when you click on some people's posts they post on Facebook, for example, it's basically spam. It'll send you to like 5 or 6 different web pages, and it'll pull all this extra stuff because people are doing an attack on your computer. And Java is the easiest to do it in. That's why a lot of people use Java, because it's simpler to do it in Java than it is any other language. Mainly you shouldn't click on anything you're not sure of, because in JavaScript you can get a malicious code in the URL, and that's when like a Flash video or image is not obvious to you or your browser, so it ultimately ends up in you getting attacked. And then spam is another way. Like when somebody sends you a spam email, it has a crafted link, it has the HTML code, and it has malicious web pages in the URL, and that basically sums up you getting a malicious URL. And when you click on it, the attacker can then see what you're looking at. They can access your information, and it's baked in there. Ways to prevent reflected access attacks would be not to click on stuff. You have to be very vigilant in what you do. You shouldn't click on suspicious links. Just because it looks legitimate doesn't mean it is. For example, unless it's coming for Google directly or the university or anyone, it might not be legitimate. You might know sometimes, like if you have an iPhone, you might get a text saying like Bank of America, blah blah blah, your account's been compromised, and it's fake web page that has all kinds of misspellings and other things that can let you know it's not a legitimate web page. And what they do is they bake it in there. A lot of the websites now are taking prevention and precautionary measures, because the reflected attacks are also known as non-persistent attacks, and they're the most frequent found because they're easier to do. And what happens is when cross-siting scripting attack happens, unwittingly you send your code to a web server, which then reflects the code back to the user's browser where it's executed, and it performs a malicious act. And you don't know what the person could be doing to your computer. They could completely wipe your hard drive. They could do a lot of different things to your computer. And a lot of firewalls, however, people can't do this. And then limitations. XSS attacks exploit the relationship that is going on between the user and the website that the person is accessing. And one method that you can do is to enforce trust in web applications and limit the code that is able to go to the same origin server. And the XSS is a type of code injection, and it's similar to SQL injection. But websites should always be testing their vulnerability for this, because if they don't, then that opens them to so many attacks and things that are beyond their control to an extent. And character coding is really important. Without character coding and doing it properly, it really opens you up for the attacks. And like I said previously, it occurs when the attacker injects a browser executable code with a single HTTP response. And the code's generally written in JavaScript. And the vulnerabilities installs keyloggers, which steal your cookies, perform clipboard theft, and then change the content of the page. So you might be looking at one web page, and then after you get through looking at it, it could be something totally different. And it happens because it's so easy. And then here's an example of the attack. And then above it, as you can see, there's an example that is done by validating input and sanitizing the escaping output. And here's how it's fixed in the very bottom screen. In the conclusion, reflected excess attacks are less severe because the vulnerabilities aren't as high. They're easier to create. You can send them to multiple victims at one time, and they can be a pain to remove from a website because it's hard to find out where they are to an extent. And they rely primarily on activation from the victim, which is why you shouldn't click a link. And I keep repeating that. You shouldn't click a link you don't know what it is, because once you click that link, you could be into all kinds of crazy stuff. You're not even sure what you're looking at. And is that all, Megan?
Yeah, that's it.
All right. You have anything else to add?
Nope, I think that's it.
Alrighty.
Do you have any demo?
Did you ask if we had a demo? No, unfortunately, that was what Joseph was supposed to provide.
I believe on one of the slides, it was called limitations. You mentioned about the same origin constraint. Can you elaborate more on this?
Same origin. We get back to that PowerPoint, Megan.
Yeah.
Same origin. Okay, limitations. Yeah, with the same origin, what happens is one method that is used to enforce trusted applications is to limit the code interacting with the date from the same origin server. So what that does, it limits the amount of information that is from the origin server to be sent to the attacker that they're trying to access.
So what is that origin? How it is defined? What does it mean, the same origin?
It's just on the same origin server, so the original server.
And what would be the other kind of server if it's not the same origin?
I believe it would be like the foreign server.
And in what way the limitation can be expressed? So I am the attacker, and I'm trying to attack some server.
The way they could be limited would be enforcing trust in web applications. So not allowing people to access your information, having firewalls, having virus protection, blocking spam email, making sure you're protecting yourself in every way possible, because if you don't, that will allow you to be attacked. If you have limitations such as the virus protection, firewalls, spam stuff, that prevents you from getting attacked.
So what you say is firewalls and antiviral software can help to fight the same origin constraint?
Yes, from what I've gathered, that's what I pretty much summed it up as being, it helps with that.
And I don't know if you can hear me, but one of the biggest precautions is not so much on the victim's end, but also the website. I mean, the website has to take, that was one thing that we mentioned here, was that the website has to put forth a lot of effort to make sure that these hackers aren't putting links on their pages and posts. And I mean, so it's coming from not only the victim's end, but also the website.
Okay, if you guys all, I have no questions. Maybe other students have any questions?
Hey, Dr. Vibe, Tobias and Cody said they haven't gotten the invite.
I just have sent the additional invitations to them.
Okay.
If you are on, if you can ask them if they received the new ones, you probably want to report that they have it. Who is making that noise? A lot of noise. Something like moving on the table. Okay, if some of you guys didn't have a chance to use the fair graders to grade the first group, you probably want to do it now, because we want to move on to the next presentation in a moment. We're still expecting 2 more students to join, and I just sent them additional invitations. So let us wait a couple more minutes.
On my fair grader, I'm not seeing the students. Like it's stopping before I can see and grade each individual person.
You cannot see names of students?
No, I'm refreshing it. I'll put it on my screen in a second. It's being pretty slow.
Oscar, can you confirm that they received the invitation? Cody and Tobias.
They said they still don't have it.
They didn't?
No, sir.
Do they check the radar emails or Georgia View? Because I sent this to the radar emails.
Direct email.
Let me give you the link so you can share the link with them. Just give me a second.
All right, Dr. Bab, I'm about to show you what I'm seeing on mine. It's not pulling up. Hold on. Right here. So I can't go down any further. All right, Dr. Bab, I'm about to show you what I'm seeing on mine. It's not pulling up. Hold on.
Can you change the topic in the instruction block and then go back to this reflected success? Yeah, that's real strange. Anybody else have the same problem? Anybody?
What problem?
On the fair grader, all cannot see the list of students.
I'm still trying to get logged in. I think I have to create a new password.
Those who use fair grader, does it work for you or not?
Yes.
Yeah, mine's working fine.
Cole, try to run the incognito window for that.
All right.
Oscar, I'm sharing the link that you can share with Tobias and Cody. It's in the chat. Send them this link.
All right. I just sent it to him.
Tobias is here. Cole, you're going to be next.
All right. I'm still waiting on it to load in the incognito mode, but
I believe Leonard was here. Did he disconnect?
yeah, he was here earlier. I don't see him down there now on the screen.
What about Stuart?
I talked to him earlier today. He knew what time it was. I'm not sure exactly what he's got going on right now. I'm still getting the same thing on the Fairgrader when I'm in incognito mode.
Can try different browser.
Yeah, I'll do that next.
Do we have anybody ready to present now?
Group R5 is ready.
We're ready.
All right, so group 5, Brenton, that's you?
Yes, sir.
Okay, what's your topic?
SQL injection.
All right, go ahead.
Okay. Let me pull up the PowerPoint.
And please share the screen so we can see it. You already did. Yeah, thank you.
Is there a way to make it so that it shows even when other people talk?
Everything is good, so we can see a screen.
Okay. So for our topic, we did SQL injection. And so you might be wondering, what exactly is SQL injection? Well, as the name would suggest, it's when SQL commands are injected into a web application through some form of user input. The injected commands can then be used to manipulate the database in various ways. SQL injection is an extremely common hacking technique. It was rated as the #1 application security risk in 2013 and 2017 by OWASP. So what makes it dangerous? I mean, users access information from databases all the time. Well, the problem is that the hacker is able to gain access to data that the developer probably intended to stay hidden. Through SQL injection, a hacker can get credit card information, usernames and passwords, or personal information about any user stored in the database. But sometimes the databases aren't strictly read-only, so the hacker can also modify or delete existing information. I'm sure you can imagine how bad it would be for someone to be able to modify their current bank account balance. But hacking isn't always for personal gain. Sometimes people just want to break things. And if the hacker decides to use the drop tables command, they can delete entire tables worth of data with a single line of code. So the two main forms of SQL injection are in-band SQL injection and inferential injection. In-band is way easier and much less time consuming. In-band is whenever the hacker can launch the attack and view the results from the same communication table. By using the error-based SQL injection, the hacker is able to gain information about how the database is set up and can use that information to get sensitive data. They can also use union-based injection, which is when the hacker uses the union command to append the content from different tables to the output of some existing displayed data. With inferential SQL injection, the hacker can't explicitly see what's happening when they enter in their SQL commands. Instead, they have to get creative to work around the system. If the web app displays a generic error that something went wrong when the hacker entered their SQL command, they can then try to work out how to attack the system through trial and error by blindly entering data and observing how the system reacts. This is Boolean-based injection. However, if the system doesn't show a database error message, the hacker can also use time-based injection. Commands like sleep are used to make the web app stop for a specified amount of time. And then if the web app stops, the hacker knows that the attack worked. This is usually done through an automated script, though, because doing it by hand takes way too long. So now you know what SQL injection is, but how exactly does it work? Well, first, the hacker has to find a website, and then they want to see if it's susceptible to the SQL injection. And if it is, then the hacker just goes on with the attack. And so I have a website here, and just, disclaimer, this is a demo website, so this is not, illegal hacking and stuff. But we can go here, and to just see if it might be susceptible to SQL injection, we can just enter in a single quotation mark, and that'll escape a SQL statement, and it'll basically mess up everything for their end of the thing, but it makes it so that it'll display an error if there is Oh, sorry, I got to enter anything into the password. And as you can see, it actually gives me basically the entire SQL query, which is really good for the hacker, but it's horrible for the website because now I can see exactly how this is laid out, and I can change basically that SQL command to be whatever I want it to be. And so let's go back. And let's just try, I want to enter in as the admin account. And let's take a look real quick, actually, at how this is all laid out. So this is probably what the statement looks like. And so this is select all from users where username equals username and password equals that password. And so if this returns true, then it'll let me into the web application. So what we need to do is get this to where it's always true. And so what's happening right here is I've already typed in admin for the previous one, but what we want to do is finish out this statement to where it'll return true. So we can close off that password, so that's closed off, and then type in or1 equals 1. And that'll basically make it so that this is all true, because or1 equals 1 will make everything always true. So then we comment out the rest of the statement. And if we go ahead and copy and paste that into the password, it lets me in. And this admin account actually has tons of access to all these people's. I can change these people's passwords and then sign into their account on my own. But suppose that this bank was a little bit smarter and they didn't give me all this access to everything. First, I would need to find out someplace I can enter in some user input, which just happens to be here. So let's see if this is susceptible to some SQL injection. Let's try it again. Looks like it is. So right there is where my input got put in. And if we take note of that, that's a name that we should probably use later on that the error code really shouldn't have given me, because now I can pretty much just wreak havoc on this database. So first of all, I'm going to go ahead and make it so that the statement will always return false, so that anything that would get output here will basically get suppressed. And so only the new query that I'm about to put in will show anything. So we do that, it works. Okay. So then I'm going to do a union select star from, let's try user ID, see if there's a table called user ID. And then comment out the rest. So it looks like there's not a table called user ID. So we'll have to go back and try again. And let's try users. So there is a table called users, but now the columns don't match up between my query and the first query with the union. So let's just put in some placeholders. Let's try one column. There's not one column. Let's try two columns. Not two columns. Three. There's not three columns. Try four. So there are four columns. And if you note, this placeholder gets shown right there. If I change this to some arbitrary value, it gets changed as well. So what I want to do is I want to put in some value from the table. And so we saw that user ID was a value in this table. And so now I have access to all these people's user IDs. But it doesn't stop there. If maybe by chance they also have the username stored in this table, now I have access to all these usernames. If they have, for some crazy reason, the passwords, put it all in the same table. So now I have their user ID, their username, and their password that I can just, those are all mine now. And that's pretty much how that works. Cedric?
Pretty good.
You there, Cedric? No, we can't hear you, Cedric.
This is mic messed up.
Do you want to go ahead and do your part, Junior?
Okay, yeah.
Check your mic settings in the panel above. Sometimes there is default mic that is not the one that you have connected.
Well, I'll go down to my part and explain how to avoid it, how to avoid SQL injections. And the number one way to avoid a SQL injection is to use prepared statements. The prepared statement is nothing but SQL statements that are sent to a database server while being parsed and separated from other parameters. But note that you can't. It's good to use it because it's the best way to avoid SQL injections. But if you use too many of them, it will harm the performance and slow it down. There's also something called dynamic queries, and the best way to avoid a SQL injection is to use whitelist filters to restrict to certain values.
Still can't
There
hear.
are there's a web application firewall that you can use also to avoid a SQL injection, where you can configure it with rules to look for a SQL injection type of attacks. You can also set up a unsafe variable and escape special characters with it, and we gave an example of how to set up an unsafe variable right below. It says the unsafe variable, you can post user input, and it'll just pretty much try to escape special characters within that unsafe variable to avoid a SQL injection. You can also use the built-in function called MySQL real escape string. It's infallible, meaning that it will always work, and it should be used on every single value. You can, after using the MySQL escape string function, you should create a second escape pass right after it to help with avoiding SQL injections. You should always do your escaping steps before issuing your queries. Otherwise, you'll be attacked right away. You should use single quotes for your values and backticks for identifiers, and always escape wildcards and regular expressions. Validation should only be done after escaping steps that are completed. And disabling your parameter blinding will also prevent SQL injections. You just need citrus.
Can you hear me now?
Yes.
All right. You can. All right. Yeah, right there. So, from what Brenton described for SQL injection, now that we know exactly what it is, you should now try to figure out if your website or your application is actually vulnerable to SQL injection. And the basic answer to that is really any web application or website that uses the SQL language to build their databases is vulnerable to SQL injection if they have like any kind of form of input from users, like we saw in the demonstration. And the main targets for these types of attacks are like web applications that require logins, like your emails, online banking, forums, and political websites that may have like logins for members. Um, and a good way and possibly a bad way that you could check to see if your website is vulnerable is to use SQL maps, and it is a penetration testing tool that automates the process of detecting and exploiting with SQL injection towards your website. And the reason why this can be good and bad is because anybody that knows how to use SQL map can essentially use this on websites, like random websites or bank websites, and they can use it to see if that website is actually vulnerable. And if it is, the hacker can then go forth with a SQL injection attack, and they could get into the databases and dump all the important information that may be available to them. And you can go to the next slide. All right. And the way that you would counteract that is that you would use automated security systems, and they're the easiest to set up without actually having to have like more actual coding. So they cut down the time that it will take to actually protect your databases and your database servers from attacks like this. And the two different types that you could use are IDS, which is intrusion detection system, and IPS, which is intrusion prevention system. And they work like an extra layer of security on top of your server firewall. So when the firewall, when it initially gets that contact from outside, whoever's contacting the servers or actively using, like, transferring data from outside to server, the firewall does an initial sweep of all that information to check if it has those bad signatures, and if it does, it'll go ahead and block it then. But if they do come in and the initial signatures match the policies that are acceptable, it can actually go in under the firewall, even if it is has malicious content. So what IDS and IPS do is they actually check the content of that of this input from outside, and that allows the IDS, which, like I said, it analyzes that input. It can match the content to certain pre-entered, like malicious activity or behavior. It can match it to that, and if it does match, it'll send a notification to you, or like an alert for you to actually do something about it. So the IDS, in a sense, is just basically like the alarm at a bank. Like, it won't actually do anything to you, but it will notify police to come and take care of it. The IPS, on the other hand, is it does the same. It's very similar to IDS, but it actually prevents the attempt from continuing or from actually doing any damage. So it'll match that malicious activity or behavior just like the IDS, and it'll go ahead and get rid of that attack. So if somebody was putting in those SQL statements and the input, it will match, do like probably irregular expressions to match certain meta characters, like the meta characters like the star, colons, commas, all the other stuff that could potentially break the statements that you already had, and it would match those meta characters and actually block that attempt from actually destroying like your database, because once they get in, they can actually dump, like Brendan said, or they could they could drop, like Brendan said, or they could dump that information into another application. So like if they get in, they could dump all that information, like usernames, passwords, account numbers, how much money is in account. They can do all of that. So that's the certain ways that you can detect the SQL injection attacks. And that's not from the slides, but something extra is they have fully built systems that can essentially give you all the information that you would need on in the case that an attack actually happened. So it will be able to give you the date, the time, like who did it, from the IP addresses. They can give you all that that important information on an attack if it does happen, and they can prevent it at the same time. So it's like a 2-in-1 with certain systems, prevention systems, and that's it.
Can you guys demonstrate the same website that you use to attack with the MySQL, not MySQL, SQL map tool?
Do you have SQL map downloaded, Cedric?
I don't have it downloaded on me like right now, and I could probably get it. I think it's Linux based, and I'm on a Windows PC. So let me try this.
But have you tried it?
I haven't tried it. I watched a demonstration on it, though.
Okay. Do you have any names of or vendors of or products for those IDS and IPS systems?
Okay. One example is Snort. Snort is it basically does both. So and it's actually a free prevention system. Alien, let me see. Alien Vault. It'll actually do what I said in the last part. It'll give you the dates, the times, and IP addresses. So it'll actually give you you can look at a time frame, like it'll constantly monitor your database.
Snort can actually do this for you as well.
Yeah, that's what I was saying. Snort can do everything too. I think Alien Vault is a paid. I think it's a subscription based. So if when you think about it, Snort is obviously like the best option because it can do everything and it is free to use.
Okay, one more question. Let us just say your database and your web server are not installed on the same machine, but they are split for the performance optimization. And your IPS or IDS system usually stays in between the internet and your local infrastructure, network infrastructure. So it protects the network, the web application from the internet. If some user, some attacker remotely tries to use, for example, SQL map and discover the structure of your SQL database, likely all requests that he is sending will go through encrypted connection that is targeted directly to the web application. For the intrusion detection system to be able to identify the presence of some triggers in this request, intrusion detection system has to decrypt the request and data stream. That is only possible if some special countermeasures are pre-applied. Do you have anything to say about this?
About that, the IDS, from what I've read, is definitely not fail-proof. It's ways that you could get around it with complex SQL injection. So with that, it would be really up to the developers when they're initially, like, from what I can tell, you should have like prepared statements for that, like beforehand, and not really rely on the system as much, so that something like that couldn't happen. And I wouldn't know exactly how the IDS would actually work with it being split like that. I didn't run across that that type of situation. I just I kind of found out the general synopsis of what IDS and the IPS do for you.
During the network lab practice, we'll use system, not actually the IDS, but a software that allows you to see the network traffic. So pretty much IDS system does the same, but instead of showing all traffic to the administrator, it analyzes the traffic. And if, for example, a request to the web application with apostrophe or some 1 = 1 expression is seen in the application level, then IDS simply triggers this. And it has number of pre-established conditions or triggers that will be activated if some data is present. But for this to work, the IDS system needs to be able to decrypt the traffic. And usually IDS and IPS systems, they are installed to protect not everything against everything. If you really want your IDS system to decrypt previously encrypted traffic, you have to make sure that those who use that web application have previously accepted some terms and conditions, and in other words, the way how they encrypt the data not only is understood by the application, but also is understood by the IDS or IPS system. So it makes the IDS IPS system to decrypt the traffic on fly, and if something is going wrong, it just logs or prevent the connections. That's how it works.
And that would just be the IPS, like.
Usually there are IPS around. You don't see many IDS systems on the professional utilization, because knowing that something wrong with your system isn't enough, because you really want to be able to automatically prevent it. If you analyze, for example, amount of traffic that comes from China or South Africa to our networks, you will be surprised that, first of all, it is actually much more traffic, much greater traffic compared with what local students generate. Because when someone wants to attack your resource, they attempt to do the brute forcing, and they send a lot of traffic. And knowing that there will be many requests to your system isn't enough. You want to stop that kind of traffic. That's why IPS systems are usually deployed in places where IDS systems are not sufficient. Anybody, any questions? Any luck with the skill map demonstration?
I haven't gotten it yet. I could probably get it later. I have to like download it and set it up.
I'll see if I can get it.
All right, we're going to switch to some other team. If you'll have a chance to make it working, we'll jump to your team later on. Okay. So, who's going to be next? Questions?
I think we're ready. If we can get our PowerPoint shown.
So, who will be presenting? Oscar, you?
No, Tobias was the wrong person.
Tobias? Okay. I see Cody is trying to share screen. Yeah. And your topic is
the web server backend.
okay. Backend data storage solutions.
Yes.
All right. Go ahead. I think we lost the screen share.
We're waiting on Tobias. Tobias' internet, his internet just went out. You said you want to pull it up? All right.
So we're waiting for Tobias to come back. Are we waiting for Tobias to come back?
Hey, Dr. Bio, there's somebody on the chat that says they can't join because it says that the room is full.
I think I'm in.
Are you good? Did you see that message that said try to join and it's full?
Yeah, I'm in right now.
Are you in the video?
I can't see anything, but it looks like I'm in. If you see the chat, if you look up like it.
If I'm not mistaken, the capacity of the room is 10 people.
I clicked that, and that got me through.
Do we have any communication going? Because I cannot clearly hear what you're saying.
All right, our group's just going to go ahead and start, and Tobias will join.
All right, go ahead.
Okay, so our project was securing the web server backend, and so we're just going to take a look at the good and bad practices, and then somebody trying to say something. Okay, so you can just go on to the next slide. Okay, so I can't hear you. All right, so most data today is stored on the back end of the website, and the back end consists of the database and the web servers. And we have an example when an online. You trying to say something, Dr. Bryce?
Yeah, I'm in the call.
I believe those who don't present need to be muted. I'm trying to mute Hamad, but your mic is still using some echo.
Oh, okay. But yeah, we have an example of when an online person is on the front end. However, the information about the user's order, his or her account, and personal details are all stored on the back end. So that puts a lot of importance on the back end, and just because it contains so much sensitive data. We can go ahead and go on to the next slide. All right, and we have some statistics showing that really just explains the importance of everything that we're discussing in this class and just on this presentation. Since 2013, there's been over 9 billion data records stolen or lost, and data breaches and data leaks are just, it's pretty astounding, just the volume of data that's attacked just every day. So you can see that every second 64 stolen are breached. And 2016 was actually the worst year to record, and 2017 has already had over 1 billion records breached. And so that's just why, the web server and the database, especially, just both of them need to be heavily guarded. If we can move on.
I think this is Tobias.
Yeah, I don't think he's not connected.
His internet went out again?
He said he was trying to connect through.
Do you want me to go on to my part?
Yeah, you can just go ahead.
Okay. Here's some more back-end security techniques. This is supposed to come after. One's images. So if an attacker gets into the web server, they don't necessarily also get into the database. And the second one is also pretty common sense, because a firewall will restrict the addresses that can access your server, only allowing certain addresses to access it. So if you have a firewall, not just anybody can get to your database. And then the third one, using authentication to restrict access to data and categorize databases within the database management system to minimize the risk of lost credentials impacting every database. So this one has kind of two parts. The first part, just using authentication, which is simple, just login credentials. And the second part about compartmentalizing your databases within the DBMS means that if somebody's login credentials are stolen, then whoever stole them can only access the data that that person was allowed to see. And so again, that's just minimizing your damages, where at least not all of your data is at risk, just whatever part that person could view. And the fourth one's also simple, just encrypting your critical data so that even if they do get the data, they can't necessarily read it without the key. Now, if I can advance the slide, but it's not letting me. Okay, there we go. So there are some possible issues with these security techniques, though. For instance, a firewall, even though it does allow only trusted addresses to access the database, if an attacker gets into some of the front-facing code, the code on the front end of the website, which does have access to the database because the front end needs to communicate with the back end. If they can alter that to do something malicious, then they can get to your they can access your database anyway. Which, as most of these things, there are ways to get around it for attackers. But the second part about both authentication and encryption can help secure database, as we talked about, but they also create new targets for hackers. So with authentication, and so your login credentials become a target for hackers. And with encryption, the encryption keys become targets. So even though you have secured your backend with login credentials and encryption keys, now both you have two new things to worry about that you might not have been prepared for, different types of attacks that are targeting the login credentials and the encryption keys. And Node.js, this is just more specific examples on a specific type of server. And Node.js is an application runtime environment that allows for server-side applications to be written in JavaScript. And since JavaScript is very popular for websites, Node.js has become popular using it for web servers, since this time both your front end and your back end, both your website and your server, will be written in JavaScript. It makes it easier for programmers to allow the front end and the back end to communicate with each other, and just in general only having to work with one programming language. And it has become more widely used due to its unique I/O model, which excels in the real-time situations that are increasingly being demanded of servers. So Node.js is just fast, and real-time situations that it's talking about, for example, would be if you're online editing a document, then editing the document in real time where other people can see it, Node.js works well for that kind of stuff. There are some security issues that come with Node.js, however, because it is written in JavaScript. All of the security problems that JavaScript has is now brought over to the server side of things. So there's a high risk of developing code in Node.js with XSS vulnerabilities because it is written in JavaScript. However, this can be easily avoided using output encoding, which is the process whose purpose is to convert untrusted input into a safe form where the input is displayed as data to the user without executing the code in the browser. Can you guys still hear me?
Yes.
Okay. Node.js allows for the implementation of a web framework known as Express.js that has a built-in cross-site request forgery prevention, which is good that it comes built in to prevent that stuff, because CSRF allows an attacker to execute a certain function on the web app on behalf of yourself. So essentially allowing an attacker, it thinks the attacker is you, and so it can access your abilities and stuff. And MongoDB is a common database used with Node.js. And as we talked about previously, the database and server need to be secured separately. So if they get one, they don't necessarily get the other. But there are two things that you need to do to help secure your database if you're using MongoDB, which, as I said, is a common one. The first one is enable client authentication, because by default, MongoDB does not force authentication to access databases. So therefore, initially, everyone has direct access to the database content, even if they do not have access to use your application. So you have to set up authentication rules for that. And also, you need to sanitize user input in queries, because MongoDB query language is based on JavaScript. Therefore, it is vulnerable to script injection attacks. So when you use user-supplied input values inside MongoDB queries, you should properly enforce type checks and necessary input validations and sanitizations to prevent attackers from executing malicious scripts on your database. And that was my stuff. Oscar, you want to go again, or does Tobias want to go?
Does anybody know where is Tobias?
Is
No,
Oscar?
sorry, I was muted. Yeah, I'm ready to go. But
Okay.
Tobias said that he's unable to join because the session is full.
But this is his part, right?
No, this is my part. I'm going to go ahead and go.
We
But,
have to go back to Tobias's part.
Okay.
All right. So we there are some techniques that are kind of that will leave your backend vulnerable, the backend of the system. And so whenever you set up and deal with the backend, it's really hard to make it completely invulnerable. I mean, even if you have good processors and good, training and everything, it's still very easy to still be susceptible to attacks because it's just, I mean, okay, so there's some things like injection flaws are when you fail to filter untrusted input, and this allows you to be open to injection attacks. And you can also misconfigure the backend, and if you fail to encrypt all of the sensitive data that's coming in and out, that makes it a lot easier for cyber attackers to just makes it easy for them to hack all of your information. And a previous group's already spoken about injection flaws, but there are plenty of ways to combat these. I mean, these are kind of the obsolete poor practices, or you could say the human error. Could you go to the next slide?
Tobias is here. He probably wants to continue.
Okay. And
Tobias?
insecure.
Can you guys hear me?
Yeah.
Yeah.
Okay.
All right, and there are many problems that stem from bad security practices whenever they get into the system and start pretty much just wreaking havoc. Databases can be heavily affected when the backups are stolen, and they can just do whatever they want with them. They can sell them or use them to hurt the company. And but an SSL and TSL encryption key can help prevent the leaks. But an insecure direct object reference is when a key or internal object is exposed to the user. That just allows the attacker to completely bypass the entire authorization procedure and then just get direct access to the material. And an attacker could also use a worm, which breaks the database, and this takes advantage of the SQL databases or the Node.js in MongoDB. Tobias, go ahead. We can go on to the next.
This is Tobias's part, right?
Yes.
Okay.
Tobias, can you say something? Are you here? You probably guys want to continue for him.
All right. And okay, so these are some of the common back interfering attacks: SQL injection, cross-site scripting, and SQL injection is one of the most common server attacks. An attacker is allowed to, create a string that uses specific SQL commands, which allows them to directly enter the database and get all types of access to your information. These strings are used in the search box, login forms, and even directly from the URL. And that's a very major type of attack. And another one is cross-site scripting, otherwise known as XSS. And whenever you're developing, you don't check to see if your code has the possibility for scripts to be injected. An XSS attack can happen. The attacker is able to create code that executes whenever the user interacts with the website, and this leaves your users vulnerable to all types of attacks. You want to do?
And these are, is Tobias here or not? No?
Tobias, can you go? Yeah, can you go ahead, Cody?
Okay. These are some of the most important ways to secure your web servers and databases. I referred to these earlier when I did my part. But here are the three, and we're going to break them down. Removing unnecessary services. We know that by default, OS installations are not secure. Many network services which will not be used in a web server configuration, such as RSS, PSS, RAS, etc. So the more services that are being run on an operating system, the more ports that will be left open. So we know that by leaving ports open, that makes it more vulnerable to malicious users to abuse. And you also need to add permissions and restrictions. So this also plays a vital role in web server security. And those are the file and network services permissions. If a web server is compromised by network service software, then a malicious user could use the account on which the network is running on to carry out the tasks. And so these tasks could be executing specific files. So it's important to always assign the privileges needed for a specific network service to run. And of course, install security patches on time. This one's pretty common sense as well. So adding security updates doesn't necessarily mean that your web server is secure from attacks, because there are occasions when updating could leave you vulnerable to attacks, but it is still important to update your operating system and any other software running on it with the latest security patches. And that looks like it's it. Didn't we cover everything? Yeah.
Yeah, I believe we did.
Okay. And so if Tobias is still not here, then I guess we're done. Unless there's any questions.
Can you compare different backend platforms from the standpoint of security? I saw you mentioned Node.js, and probably you can say something about others.
Yeah, I know Oscar researched Apache, I think, or MySQL.
Yeah, I did some research on Apache server and then the MySQL database, and kind of I was looking at like the secure their data, like their backend.
If you compare Apache with MySQL against Node.js plus Mongo, can you make any pros and cons for both?
Well, I know that
my pros for Node.js is that it's written in JavaScript, because that makes it good for web servers, since your website's written in JavaScript, or a lot of them are, and so that makes it easy for the server and the front end to communicate with each other. But then, like, that's also kind of its downfall as well, since, as I mentioned on this slide, that JavaScript does have some security vulnerabilities, and that brings it over to the server side. So JavaScript would be my pro and my con for Node.js. And then Oscar, if you want to talk about Apache.
Okay. Well, MySQL, it has a lot of like really secure methods. Like, I mean, they have very extensive like resources put into their security. So when you use MySQL, it travels on an encrypted line, and that makes it really secure. And it's also written in C, which is what you use for Linux. I mean, for Linux and Unix, I believe you're using C, right?
For Windows, I think that's Apache and MySQL, and then Linux. No, that's Linux. I'm sorry.
But I agree that Node.js is probably the better web server to use.
But still, there are thousands of millions websites driven by Apache, driven by PHP and MySQL.
Yes.
So you're probably not correct to compare Apache with Node.js, because Apache is nothing more but the web server software. If you want to compare Node.js, it's probably better to say you correct Node.js version of the JavaScript with PHP.
Okay.
Node.js works only with JavaScript, but Apache supports not only PHP.
Okay.
And when you say that JavaScript as the language itself is vulnerable, it's not exactly true, because the subset of JavaScript that you use on the server side with Node.js, it's a bit different than the JavaScript that you run on the front end in the browser. And for example, MySQL SQL injection attack that you do with the help of, or cross-site scripting attack with the help of JavaScript on the front end, it has no sense when you run it against the backend in Node.js. So it is the same language, but the application is different. So I would say this statement makes some sense, that since it is JavaScript, then probably you want to, you will see situations when, say, someone who is professional in JavaScript will be able to write a malicious attack against such a system. But the separation between the front end and the back end makes it clear not to use the same JavaScript on the front end and then back end. They are just different subsets, different parts of the JavaScript. For the fundamental purposes, you still use JavaScript like loops, conditions, but the Node.js is well known for its because it supports modules and libraries, and this is actually the greatest issue with Node.js applications, because when a web developer uses some libraries, or they call it packages, in Node.js application, you usually rely on the fact that that application or that library is reliable and is secured. Recently there was a research about Node.js applications, and it was published very scary result that more than 50% of currently running Node.js applications are vulnerable due to the fact that they use modules that have been hosted in GitHub. And when certain code or certain library is hosted on the GitHub as the open source platform for open source contribution and collaboration, the default credentials can be seen in those GitHub repositories. And whoever uses these modules, these libraries, they don't change default credentials found in the modules. And for example, if an attacker will figure out the way that particular application is written with Node.js and it uses particular module, they probably already know the default like secret that can be used to attack this application. So it will not be attacked against JavaScript. It will be attacked through the backdoor, and that backdoor was left open by whoever who created the module.
Okay.
That's the greatest scary thing about Node.js applications. Of course, if you properly choose your modules, if you at least read some feedback about other users of the same module, then you're likely safe. This situation is not that common with PHP because PHP modules are well more sanitized and secured compared with Node.js modules. But choosing between these two, you probably want to choose Node for its portability and existence of that huge collection of libraries. But you want to choose PHP if you a classical web developer and don't need any fancy, just want something very straightforward. All right, thank you guys. Who do we have next?
Yeah, and I've talked to Braxton and Leonard, and they're both in the chat, and they can't get in because of how many people are in here.
All right, can you present their part? So we share your grades for them.
Well, I don't have any of their information.
All right, let us do this. You present your part first. Is your part the first part or not the first one?
Mine's the last part because it's the demo.
Okay, I probably need someone to sacrifice your connection to allow other people to join.
I'll disconnect mine, but I'll go try to get on with somebody else.
All right, we now have at least one spot.
I'll back out too.
All right, thank you guys. So, no, not everybody. Okay, Braxton, I see, and Leonard. So, who has the first part?
I guess Leonard, he was doing the information, and then Braxton was doing the examples. So.
And which part is the first one?
I guess Leonard would go first.
Yeah, it'd be mine.
All right, Leonard, share the screen and go ahead.
Give me just a second to get it set up. Okay, I don't actually, can you guys see it? I assume so.
Yes, we can.
Okay, all right, so we did stored XSS. So it stands for cross-site scripting. I know that the Reflexive guys did, before I get disconnected and kicked out, I know that they did the Reflexive. So it's the same deal, but instead of trying to infect the user's browser, it's an attack directly on the website, and basically it finds a vulnerability and the attacker injects a script into the website. So every time that you visit that website or use whatever that they've infected, it executes a script. More often than not, this is used to steal cookies or other forms of credentials, so that when they visit the site, they can use your cookies and impersonate you on that website. This is just a graphic. Basically, you can see the perpetrator will infect the website. The visitor will come in, visit the website, and when they log in, the perpetrator can then take their cookies. So, or take anything else. Like it's also used for keylogging. We'll get into that in a minute. Whoops, I didn't mean to go back. Okay, so as opposed to, like I said, infecting the user's browser, it infects the database or the website itself. So HTML, PHP, JavaScript, basically any website that uses the basic code to form website is vulnerable to this. SQL injection, which I know that's another group, is a form of this. So databases can be at risk. But yeah, the common areas on a website that are usually target are comment fields, user logins, forum comment things, basically anything that the user can put information into and submit is very vulnerable to this kind of attack. So practices to detect and prevent. For detecting it, there's literally not much you can do except for testing it. So you'd have to go through and find where in your code, anywhere that the user has to submit info, and try to run a script via submitting it like they would. And if it runs, then you're vulnerable and you need to fix that. So that leads into preventing, which you do like JavaScript escaping or HTML escaping. And if you don't know what that is, it's basically you, instead of having the actual symbol like register, like you basically, when they go to submit a user field, if any of like, you can say like any of the key characters, like in HTML, like the ampersand sign or like the brackets or anything like that, if those are in the comment field, you can just be like, those are invalid characters and it won't do anything. Or you can use the sanitizing library, which they're usually user-based or like user-made up. I know I found a few online, and you can just like run that and it'll, or you can add that library to your code, and when you use it, basically it'll do exactly what I said, but it's more like streamlined and moderated, and you can just like call a command and then in the user submitted stuff, and it'll take that, run it through the library, and if the library finds that they're trying to like run a script or something, it'll just shoot an error. On the user side, it'll just shoot like, this is invalid. On your side, it might say like, they're trying to run this kind of script or something like that. So for testing, I pulled this from a website. So basically, you can see in the bottom there where the user submitted stuff is. They ran a script up at the top where it's like alert document cookie, that kind of thing, and down at the bottom, that's what it comes out to. So like if you're not protected, it'll run the script, and that's how you basically like. It's a pain from what I can understand to like try to whatnot, because you basically have to go line by line. And then preventing. This is just like, I didn't go through like the libraries or anything. This is basically just like a base overview of, you need to escape the data if you're trying to put it into anywhere that would look like this. So yeah, if the user is like looking to put in info, like escape it before it continues on through the code, or otherwise they could probably infect. So that's where I pulled my info from. OWASP is a fantastic website, I will say that. So that is my portion. I think I'm throwing it over to Braxton for the rest of it.
Can y'all hear me?
I can hear you.
Okay.
Yes, we can. We're gonna show the slides. Okay. See it now.
Yeah. Okay. All right. So these are, my portion was, doing some examples of the stored excesses or cross-site scripting. So, just another brief overview of what stored excesses is. It's also known as persistent. And the reason it's known as persistent because if the attacker, nests a script into a website or a forum or something, it'll stay there until the admin is able to find it and remove it. Websites that you like share content on, things like forums and social media, they're really easy for attackers to use stored XSS through these means. So right here is just like an example of the process of it. So the attacker creates a script, and the script is going to be nested within these two. I forget what it's called, but like I said, the attacker puts the attack in the script and uploads it to the website. So anytime a user visits that website or that forum, their browser will automatically be affected with it. So, and one way they can do it, like I mentioned with the forums, like I said, they can put like a tag inside the script, put it in the forum. Anybody that visits the forum, their browser will get infected with it. So here's like another example. This is on a forum where the attacker put the attack in the topic as well as the message, uploaded it to the website. So whoever one way that the attacker can get the attack to show up is, they can put popular keywords in it, so it'll be a popular search result. Right here is just saying that social networking is another platform which can be used for stored XSS. And this right here at the bottom is like an example of a virus, maybe I would say, but So this right here is a code of a just like a basic application that'll bring up like a text box or something where users can enter information. So an attacker can put the JavaScript inside that text box that's gonna come up and ask users for their information. And anytime the user accesses that text box or types something in, their computer will be affected. Like Leonard said, they can steal your cookies, steal any kind of data from your browser, IP address information, things like that. Like I mentioned, cookie stealing is one of the goals of store XSS. Right here explaining how an attacker would start. They would create a .php file, and a .php file, allows you to obtain things such as cookies and data from another browser. So like within that PHP file, the attacker will put the code. So and then the attacker would create a text file. And the text file is for the purpose of holding the contents of cookies or the IP address details once that attack gets it. I got an example of a cookie stealing code right here in the black. So an attacker can put that at the end of a URL for a website, but if it's in between the scripts, whoever's visiting the website, they won't see it. They'll just see it as a regular URL. And then once the link is followed by a user, their cookies will be stored in the TXT file. So that's how the attacker obtains cookies by using stored XSS. And some of the prevention methods, want to have heavy validation of your input and escaping output. Try not to use untrusted data or accept untrusted data into HTML, but if you have to, there should be an HTML escape before inserting untrusted data. And another way to prevent it would be to filter out the word JavaScript, because JavaScript is the most common way to use it. So that's my portion, and I'll be turning it over to Cole. All right, my portion was the live demo. I'll pull it up right now. And what I used was an application called WebGoat, and it's an intentionally insecure application where you can go and test malicious code out. So basically this is a forum, and let's just type in hey, and then we come down and
we can see that you can see the title and the message. But one thing about forums, like what was said earlier, was that they accept different types of like HTML and scripts that you can type in. So what a hacker would do would be they would test out the system to see if it allows for HTML code to be inputted. So put that in, submit it. So when a person goes and clicks on the message board to test, they get a pop-up, and once they see this, they know that they can input other stuff into the forum, and that the forum's able to be hacked. So let's see. So someone could put in something similar to this and fill it with malicious code. And they could get a pop-up that said this, you've been infected by an attack. Okay. Another way they could do it would be to redirect the user to a different website that was full of code. So submit that and go to that, and you would be directed to a website that had malicious code, and then they can infect your computer that way. One of the other ways to do it would be like they were talking about steal the cookies. I did have a little problem with this. For some reason, I'm just getting a blank message when this is typed in, but this is the correct thing that I found online. And for some reason, like I said, I'm just getting a blank message. But what should be up here in this box is this right here, the value and the session name, which is the actual cookie. And I believe they also showed this other code. So basically, they would type that in to steal the cookie. And then they could use this right here to direct it to their site. And once it's directed to their site, they would be able to store the stolen cookie onto their server. And then once that happens, they could retrieve the cookie file and use like a browser or a plugin to authorize the stolen cookie session and then log in and impersonate that person. So basically that's how it works, and I can't really demonstrate a way to block it because like they said earlier on our slides and stuff, that you have to actually go in and modify the code to, you know, block out your brackets or any kind of HTML. So I wasn't able to show any ways to block it, but that's basically how it goes.
Can you comment on where else stolen cookies can be used, except just to impersonalize somebody?
I mean, just they could also, you know, have actual viruses in there. So once they clicked on the URL, then they would be, their computer would be infected because the virus is already stored in the URL itself.
Virus is stored in the URL?
Well, I mean, it would redirect them to a site that could, you know, once they click on there, they get redirected to the site, and then the site could, you know, possibly have malicious code, which could, you know, do harm to the computer.
Yeah, that's better. Is it all?
Yeah, that's all I got.
All right. Thank you, guys.
Do you want us to just hop out so other people can get in?
This channel can be viewed in YouTube without joining, so everybody who is not presenting can actually leave the Hangout and join the YouTube translation.
Okay.
I actually can share the link with everybody on the chat. I'm not sure if you have access to this interface, but in the chat, I'm just sharing the link. You can just join this translation for the purpose of observing others' performance. In this case, you will not occupy the spot, but will be able still to grade other students.
Okay, that's great. Well, then I'll hop out.
Right. I believe we have the last team.
Yeah, we're waiting on Taylor to get into the chat.
We're going now?
Yeah.
I guess. Oof.
Oh, Dr. Baez.
Yes.
Since this is a stream, we can bring it back to see the first group that my group originally missed.
Can you say it again?
My group, me, Brent, and Cedric, we missed the first group when we finally got in. Is it on the stream, like all the way in the back, where we can view it so we can grade them?
Yeah, that's on the stream that is recorded. So
Okay.
you'll be able to watch it.
Okay, I'll go into the stream and then watch over, and then I'll bring it back to the front to catch them.
All right.
Okay.
So you ready to start, guys? I believe you all are here.
Yeah. We're waiting on Taylor to bring it up.
But he's here. At least I can see him. Taylor, can you say something so we can check you speaking?
Yeah, I'm sorry. I just had to put the dog up. Yeah, sorry. 1 second. I'm about to screen share and all that stuff. It would just let me. There it is. Unmute myself real quick.
Yes, I can see the slides.
All right, are we ready?
Yes, sir.
All right. Oh, wait. Alex, you starting? Alex?
Who is starting?
I thought it was Alex.
Alex.
Why is he not saying anything?
Hey, Alex.
Can you reach him by phone? or any other means?
Yeah. He said, oh, he's getting his mic to work. He said his mic got out. Hello? Your mic?
It's not cooperating right now.
Okay. I can go first then if that's the thing. I can just go first and then you can come whenever you get your mic working.
First, I'll try and get this working. I'm going through the settings and I'm looking at it and it's not showing up.
Okay. Taylor, bring up the PowerPoint.
I'm taking my microphone to work earlier when I was in the call.
Hello?
Yes. You want me to point? All right, I'm ready.
Hello?
I'm ready. You ready, Ahmad?
Can you guys hear me?
Yeah.
Yeah. Go to slide, I think it's 8 or 9.
So we don't start from the beginning?
Yeah, can you go to slide 8 or 9?
Is that the one you want?
Oh, this is the first, and his mic isn't working right now. So he's getting his mic work, so I'm gonna go, and then he's gonna come back. Yeah. The next one. Okay, so we're gonna talk about the exact cause of the Stack Overflow error. Each stack is allocated a certain amount of memory, and the beginning of the stack is for your statistical information, and then it has the rest of it that deals with the actual information in the stack. Well, if too many things, too many interrupts happen in that stack, the stack pointer keeps increasing to, it will start pointing at registers in memory that isn't actually in the stack and will cause corruptions in data and the stack to interrupt. And this is, okay, you can move on to the next slide. Okay, this is one of the most common screens you'll see when you actually are getting a Stack Overflow error. This is C# Stack Overflow exception is being handled. This is typically the message that you'll see when you're dealing with Visual Studios. Right now, if, it's pointing at what it believes to be the error was caused, and it's being caused by a loop adding something to the register too many times, and it's causing it to overload. If you continue. Here is, we've switched to C, and this is showing that this is showing the same thing. This is kind of showing, this is in showing the pointer, and it just keeps increasing the pointer and showing you until eventually the stack, and it's going to create that exception. It's same as in the last slide where window popping up, the exception was handled instead. Here you go to the next slide. Linux works a little bit different. Linux, their stacks are fixed. So they're either between they're either 4 or 8K. And for Linux, there's no way to prevent an overflow like how you can get around it in other languages. The Linux here, reading, there's no way to get around it. And that is a lot of exploits. A lot of people exploit the use of stacks to get into information that they're not supposed to and gain accesses that they're not supposed to. There was a workaround to where you can data. And can you move to the next slide, please? Okay. So now, you know, they can be exploited, but we're trying to prevent it. So when you're preventing, you don't want stack overflows. There's things you have to pay attention to. And one of the most important things is the actual size of your stack and how your stack. So the size of your stack is determined by several different factors. For one being the size of the pointer, the size of the integers, however much information you assign to the stack to begin with, any function that calls or uses the stack, any variables that you would assign within the stack, and also any recursion of functions going back and forth in the stack. They all affect the size of the stack and they make it predictable. You need to have some form of the size of your stack before you begin working with it. Can you move to the next, please? Okay. How many stacks should be in this? So there's to that you also need to know the different types of certain different types of stacks. You need to know what system your stack is using. You also need to know whether your stack is being pushed up or pushed down, which Alex will talk about later. These are some of the common we have a single stack, which is kind of the classical approach, where the function returns addresses, parameters, variables. You know, this is kind of seen in like your 32-bit operating system that you see now. Your 2 stack, the R stack and the C stack. This is more in like your hardware return stacks, your very basic, your 8-bit processors. Your 1 stack is going to be for the actual functions, and then the other stack is to handle exceptions. That's it's very, for like embedded systems that don't have too much like processing power, you need a system like this because you could crash the whole system, where rather if you can just handle the exception, maybe you can restart the system and save yourself some damage. Per task, that's going to be used on your more modern operating systems. And it's still, you're going to have one for your task, and then you're also going to have a separate one for your exception handling as well. And can you move on to the next slide? Okay. These are some techniques that you can use to help, some of the key things that you can use to help stray away from stack overflowing. To avoid deep recursions, as I said earlier, when you're trying to determine the size of your stack, if you're going in your stack over and over again through multiple recursions, you're going to keep increasing your stack, and eventually you're going to overload it. So it's a good idea that when you're dealing with a limited stack space, you should avoid using such things. Also, keep your variables. Don't create huge variables and try to store them. Try to keep your variables simple to help conserve space. And also the arranging of your task also is very important, which we'll talk about a little bit in the next slide. So here we have kind of the top part of a stack, and you'll see we have 4 different tasks here of all different sizes, arranged in a way to where the ones with the largest margins are going to be up top. We want to save the stuff with the stuff that is most likely to overload. You know, we want to stay that closest to the actual free space in your stack, if you have any free space in your stack. You don't want to stack them to the point where, you know, task 3 is above task 1 and task 3 overloads, and then it's going to go into task 1 and completely mess up task 1 process to help save some time and some space. And as you see here, in this case, even if task 3 does overload, there's free space for it to overload into and help saving the whole process as a whole. Can you move on to the next slide, please? And these are just some helpful tools and tricks to also help. By utilization of your memory management units and your memory protection units, you can help catch stack overflows before they happen, or maybe find dangerous areas to help reword. And you can use things like stack painting, which is basically you take all your processes and you see the worst case scenario. You use that to help frame your planning and frame your stacks to help prevent overflows. The same with, all right. And I think that's my last slide. Alex, did you get it working?
I'm afraid we can't hear you.
He said his mic is still on the fritz.
We would help him to reboot the computer.
Yeah, if you do you need to restart? If you need to restart, you can go restart. Taylor, are you ready to go?
Yeah, sure. Want me to take over for Alex, or with the
Yes. Let's give him a little bit more time. Hey Taylor, if you need to restart, go. I mean, Alex, if you need to restart, go ahead.
So we're waiting for Alex to restart.
I guess so. Sounds like.
What about your part? Is it the first or the second, Taylor?
My part was more due with the demo so much as, but as close. I mean, I kept looking up tutorials and whatnot, but I couldn't ever get it quite right. I could always get the segmentation faults, but I could never get the shell code to work right. It was like invalid or illegal. And so basically what we have is like a real quick YouTube video, and I guess and I know I can explain over that, but as myself, I do not have like the capability of, you know, making a buffer overflow attack at the moment.
If you were to choose the programming language to attack, which one would you choose, C or C sharp?
I would at the moment I would go C, because that's pretty much been my my experience so far. I've only used C sharp for class and like the few times I tried Unity, so I'm not really comfortable with it. Whereas with C, I know I can make an overflow attack. Whereas I basically have a variable, let's say buffer, and I make it say 10 character, or a character variable, and I make it 10. So then I just then I just send. Basically, I'm sending in data. Let's say just A over and over again. Say I don't know 16 times, and that'll overflow it. Give me a segmentation fault.
Did you see anywhere a statement that languages like C# or Java are not vulnerable against Stack Overflow?
Did I see how similar high, low-level languages are not vulnerable to overflow?
The opposite. C# and Java, they are not vulnerable. They have built-in protection, and there is no way for you to exploit Stack Overflow against Java or C# code.
Yeah. Yes, there are they will throw an exception or a warning, an exception, and say, hey, you can't do this, or you really shouldn't do this. And yeah, it will do that. Whereas C, if you do, I believe you have to find out manually. Whereas it won't tell you it won't tell you as well as say C# or Java would.
What is important, programming languages like C or C++, they do give you all the power to allocate the memory. So if you want a buffer of 10 characters, you can create, and the rest is your responsibility to not to overflow this buffer. When you deal with languages like C# or Java, you totally rely on the memory allocation mechanism that is implemented in the corresponding framework. So in Java, this is Java Virtual Machine. In C# it is .NET Framework. And pretty much you cannot just obey the rules of the game because the program wouldn't be started if it has the code that violates the execution. So instead of, for example, triggering Stack Overflow attack on C# or Java application, you would have an error message that index boundary is exceeded, but it will be caught and properly handled by the Java Virtual Machine or .NET Framework. In case of C application or C++ application, there is no such a level, such a wrapper around your program, because when you run a C application, it directly communicates with the operating system. A Java program or a C# program instead, it communicates with the framework, and then framework communicates with the operating system. So if something wrong with your Java or C# program, it will be the framework that will detect the problem, but the framework itself will not create the Stack Overflow situation.
Yeah.
So that's why C# and Java programs are not vulnerable.
Okay. Yeah, with like C++, like, yes, it's more powerful, I guess, in the right hands, assuming is used effectively. But with, like you said, C# and Java, the framework, it does kind of have the handrails to where, like, hey, this is overflowing. You need to stop. You need to redo this a different way.
That's correct.
Okay, so
is Alex here?
Alex, you there?
Oh, he.
Hello?
I think he's resetting his.
Hello?
Oh, there he go.
Can you hear me?
Yes, we can.
Yeah, we can hear you.
Okay. I'm sorry about that.
It's all good.
I had a little freak out there trying to get it going again. It wasn't wanting to open.
All right, go ahead.
Okay. Stack overflows are when the buffer overflows into the next one. It's the oldest known exploit because of how memory was left up to being managed by the programmer of whatever language, like C and C++ and assembly language. You had control of the buffer and where you were setting the address, so it was easier if you messed up to exploit and have an overflow happen if you weren't watching. Again, I said it was C and C++ and assembly are probably the most vulnerable programming languages for it. Next slide, please. I mean, it's more likely to happen again, as I said, because of how they manage memory and how they have like direct control over it. There's no virtual RAM. It's like physical memories directly handled through the compiler or the program. There. Can you move on to the next slide? Taylor?
You're in memory location?
Yeah, memory location.
I'm there.
All right, so in C, memory is allocated using the malloc. You can specify the exact amount of memory, the location you want it, and Fury will deallocate it. C++ works much in the same way. You can allocate it to memory using the new command, and then you can deallocate it using delete. In assembly language, the best to my memory that I could remember while looking this up was you can use the move command and move it directly into registers, and then you can put it into stacks. And it's the actual addresses with that one you have. Can you move on to the next slide? This is just a makeup of how a stack is. A stack limit is the smallest address. If it goes smaller than that, it overflows. The bottom of the stack is the largest address, and anything within that range is usually valid. The stack pointer points to the smallest, but anything less than it is useless, not important, or an overflow. Anything greater than it is valid. That was my last slide. I think there's one more slide, pushing up and popping out. A registry can be pushed, using the pointer, small values, and copying it, the pointer to a small value and copying it to a stack. It's a way of saving contents of a register into memory. Then you can use the pop command, or you can use pop to pop it out of memory and back into the registry, so it can be used again. This is also, you can save the information, and that's like where your program's running. It's running in the memory. That's where it has all the information and the code that it runs. And I think that was the last slide of mine. No, that slide was supposed to be deleted.
Oh. Okay, yeah.
Oh,
Then
okay.
There's sorry. And here are the references that we used. Basically, this is sort of what I tried to do, except the only difference is that he doesn't use shellcode at the end. I don't know if you can read it, but basically, he'll have his two variables. He'll have his main one with like 5 characters, and the second one with 10. And we'll just move on. And then he'll spell his name or spell a name with 5 characters. Everything's fine. But when he runs it with all these Ks, it'll go into that, and the overflow from the input of the argument will overflow into the next of the memory of the next local variable, and so on and so forth. And then it'll eventually abort because it has this sort of kind of segmentation fault. And it's the way how it goes over into the next variable is kind of like how I was trying to show. Basically, when you only have the one buffer variable and you go over it, you try to get it into I believe the return pointer or the return address. So when the stack returns the memory location to go, like that's how it knows when it returns I believe the memory location of main, and when it's done, it goes back to main. Well, instead of going back to main, you'll have the memory location of, say, a function or another piece of code that has your malicious malware or bug, worm, whatever code of shell code, let's say to start a new terminal, a new bash terminal or whatever. So you'll have your input or whatever, and you'll tack that on in the end, just right at the end of the overflow. right where it's supposed to. So when you return it, it goes to there, and then whenever it hits there, whatever malicious attack or whatever you can want to do, you'll be able to do it. And that's basically what I wanted to show, but I couldn't. The VMware or the VM box wouldn't work with me, and I tried to do it on my little Raspberry Pis, but it's not a all the tutorials I find are on Intel processors, and I'm on ARM or ARM or whatever, and that's a difference with how the architectures and whatnot. In the assembly kind of way, it's kind of similar, but in terms of registers and memory addresses, it's different. So
when you are an attacker and you want to exploit Stack Overflow, say you do know that certain application is vulnerable, what will be your step to figure out your next move?
So, assuming I know what.
Assuming that you know that some application is vulnerable to Stack Overflow attack, so what would you do to actually exploit it? Because breaking the application isn't enough. You're not that much interested to run the application and see that there is an error message printed in the command line once you started the application and Stack Overflow was shown. That's not going to be your goal. Your goal will be something else. So what is your goal as an attacker with Stack Overflow attack, and how would you pursue this goal?
Oh, from what I've seen, it's always, you broke it, and then, but at the end of it, eventually with the shell code is that it'll run whatever you want on it, I guess.
But how do you know where and what shell code to insert? Because usually when you attack the Stack Overflow vulnerable application, you exceed the predefined length of the buffer. And first of all, you have to know what is that predefined length of the buffer. And the second question you have to answer is what exactly to write into that overflown buffer such that your attack is successful. So how do you know what to write there?
Oh, I believe the memory location going little Indian. Whereas let's say it's let's say the memory address of the code I want to use is 0x000104E8, and then you'll try to fit that in, and then you'll put in \x E8 \04 \01 and so forth, and that'll be your code.
But you really want your code to be the shell or some other form of communication that you can control. It's not going to be just a few bytes of the code that you insert at the end of the overflown stack. What I'm trying to say is that a typical Stack Overflow attack cannot be just conducted without observing the state of the CPU registers and state of the memory. You really want to execute some form of the debugger that will open up the content of your CPU registers and other important information, such that when Stack Overflow is happened, you can put the breakpoint, and then step by step you can trace what is happening within the CPU that was affected by the Stack Overflow attack. And pretty much from observing the content of the CPU registers and the value of the stack, you should be able to predict what will be the behavior of the program once the stack is overflown. And then you change this behavior, for example, to activate the shell code, that is injected into your buffer. So first of all, you have to have a debugger available if you really want to exploit Stack Overflow situation. And then, so yeah, something similar to this, but with the command line debuggers, it's not that convenient. Usually you want to jump back and forth and observe many locations in the CPU registers. But the idea is that you write an exploit to the application after making sure that it is vulnerable to Stack Overflow. So in other words, you, for example, know that an application is vulnerable, you execute it, you see Stack Overflow in action, and then you repeat the same while having debugger running in the background. When Stack Overflow happens, your debugger gets activated, and then you observe the state of registers and create the malicious code that can later on be injected in the form of the machine codes into your buffer. So pretty much at the end, exactly at the point where your buffer gets overflown, there will be no characters like A, B, or C. There will be machine codes to be considered by the CPU as the continuation of the program. And the general idea of the Stack Overflow attack is to write something in the memory that will be later on executed by the CPU. So you are trying to inject to actually make a change in the program internal by means of providing some user input. Usually the memory of an application is protected by the operating system, because when the program is running, operating system must guarantee that program data or program memory cannot be modified. When Stack Overflow occurs, the rest of your buffer, the remaining portion of your buffer, the one that actually causes the overflow, contains the machine codes. And those machine codes are getting written into the program memory that is later on will be activated and will be used by the CPU to execute. So instead of continuing to execute the normal operation that are intended to be executed in that program, the operating system and the CPU will be executing the code that you have injected. And that code will be to start up the shell or some other interactive process that you can later on use. So I really, if you want to dig further, I would recommend you not to stick with YouTube demonstration that show examples of Stack Overflow, but find ones that at least have the debugger running in the background. Those will be better examples.
Yeah. Yeah, I found a good one for Kali Linux, but that one was for the Intel processor, and I was on something else.
I'm pretty much agree that ARM processors are less discovered against Stack Overflow, but they are not protected by design. You can have Stack Overflow even on ARM processor. It will be a bit harder to do.
I found out.
It will be a bit harder to do because it is less documented, and there are not that many video tutorials that demonstrate how to exploit Stack Overflow on ARM processors. But pretty much if you just have resources to run a virtual machine will inherit the CPU instruction set. So if your main computer is Intel driven, your virtual machine will be seen as having Intel processor installed. So yes, you can exploit Stack Overflow for educational purposes within the virtual machine.
Okay.
No need for you to use Raspberry Pi for that purpose.
Yeah. All right. Thank you.
Can you speak louder?
Thank you.
Okay.
Yeah, it's like, but I did find one and I tried to follow his as best I could, but apparently even with ARMS, there's still a little bit of difference. Yeah. Once I figure out how to get a virtual box or whatever settled.
Can you move back to the slide that, maybe not the slide, maybe your browser tab that was just before this one?
Oh, this one?
Yeah, just scroll it up a bit. ASLR, can you see this abbreviation on top?
ASLR?
It's in the middle of the screen right now. It's ASLR off, just before the echo 0. Oh, go back to that place.
Oh, there.
Yeah, ASLR. Did you have a chance to find out what it is, ASLR?
I did not. I didn't.
This is the technique that is used in modern operating systems to actually prevent consequences of Stack Overflow. The idea is when you start a program, usually the program file located on the hard drive gets mapped into the main memory of the computer. So pretty much the binary image that was previously stored on the hard drive is now loaded into the main memory. And knowing the pattern while it is stored on the hard drive, you probably can guess where particular functions or instructions in the main memory will be. The ASLR technique allows operating system to actually randomize position of certain functions. So for example, there are 5 functions in your program, and on the hard drive, the compiled image of your program on the hard drive has them sorted in certain sequence, like function 1, function 2, function 3, etc., etc. ASLR system, it's actually a feature of the operating system, actually a feature of the compiler that is supported by operating system. But what it does, it at the runtime of the application changes the order in which functions are sorted in your code. So in other words, when you exploit buffer overflow attack or stack overflow attack, and you want to create a shell or exploit for this application after seeing that actually is vulnerable for Stack Overflow, you really want to write assembly code or machine code that will bring you to a particular function, because usually when a function has some space reserved at the end of this, you can write your own, you can inject your own code over there and then make sure that this function is getting called. ASLR makes it very hard to find a particular function. Actually, effectively, with ASLR enabled, after exploiting the same program over and over again, you will have different appearance of the program image in the main memory. In this case, when you have developed an exploit for an application, it will not work every time you start and you exploit Stack Overflow. It will be probably working every 10th time, or maybe even less than that. That's why they always in these tutorials recommend disabling ASLR feature, because in this case, the static image of the program in the memory is guaranteed, and you can actually analyze that image and create the exploit such that every time you will run the application and every time it will be the Stack Overflow situation will trigger, then every time it will be exact same program and your exploit will work fine. With ASLR enabled, that's not going to work.
Okay. So ASLR just makes it much harder. If
not much harder, yes. It actually randomizes the program
okay,
image
so
in the
the,
memory.
so the memory randomization.
Pretty much, yes.
Okay, yeah.
But it doesn't do it just randomly. It more looks like shuffling of the set of functions along the area of the memory.
Okay.
It doesn't shuffle the individual bytes. It shuffles the functions
Okay, that explains why I have different memory addresses for a same function.
That's pretty much the reason. If you don't have ASLR disabled. If you have it disabled, then...
I didn't know it existed till about a couple minutes ago, so it's still on. Well, thank you. I'll write that down real quick.
All right. If you're interested in getting more experience with Stack Overflow, probably not during the summer semester, but if you stay longer with us during the fall, I can set up a virtual machine for you to play around with Stack Overflow, and you will be able to not just exploit it, but actually experience in writing exploits for the Stack Overflow.
Okay.
You should be able to do it at home, but I think I can provide you some guidance on that process. And that's not only for you, it's for everyone. If anyone wants to practice with Stack Overflow attack, we can do this. It's not part of our network security lab. It used to be once a couple years ago, but not this year because students are usually not getting it quick. And I decided to move it away from the practicum. All right. Thank you. And I believe your team was the last one.
Oh.
We don't have anybody else. So that's the end of our presentation series, and that's going to be available, and I will share the recording for this. Pretty much the link that I previously shared in the chat is going to be good for watching this video over again, and I plan to include this link on the detail page. So in the announcement blocks, everybody will be able to see it again.
Okay.
All right. Thank you, guys. That's it for today.
I'm sorry my microphone had issues.
Not a problem, Alex.